We have with us our the senior research analyst at Exawatt, Molly Morgan. Molly will share her perspective on whether advanced solar technologies can be cheaper despite high upfront cost. Molly, welcome to TaiyangNews. The floor is yours.
Thank you. I will just share my screen. There we go. So I'll start by saying thank you to TaiyangNews for having me on the online conference today. My name is Molly and I'm a senior research working in Exawatt's solar team. And Exawatt have been analysing cost, technology and market dynamics of the solar industry for over 10 years now. In my talk, I'll be speaking about the insights from Exawatt's latest PV technology white paper, which will include these 4 key takeaways. I'll start with introducing the current status of module efficiency in the market today and how the technologies of today improved in order to get where we are now. I'll also briefly talk through other module performance parameters. And finally, I'll discuss the modelling performed for the white paper and discuss how the different technologies compare at the system level in terms of energy generation and how, for the advanced technologies, this may translate to financial savings for both residential and commercial scale PV installations. Okay, so I'll start with module efficiency. And here we have a graph showing the maximum module efficiency of the key technologies of today. This is presented here on a 3-quarter rolling average, and we've just done this to more clearly display the efficiency trends without the fluctuations that come from manufacturers adding and removing data sheets from one quarter to the next. This data is an extract from one of our quarterly reports, and it's built on analysis of module data sheets from key module manufacturers. So it's pretty clear to see from this graph that the back contact technology, which is marked as XBC here at the top of the graph in orange, currently leads the market in terms of efficiency by quite an impressive margin. But this wasn't always the case. And you can see that back contact used to be comparable to heterojunction and TOPCon in terms of efficiency in 2022. And at that time, back contact, it didn't look that beneficial in comparison to the best performing heterojunction modules. However, in the middle of last year, back contact established a clear efficiency lead. And at this time, we saw manufacturers such as Solar and LONGi turning their attention and their R&D efforts to the technology and driving efficiencies higher. Then at the other end of the graph, we have Mono PERC. In 2021, the efficiencies of Mono PERC began to level off. This was partly driven by Mono PERC reaching its efficiency limits, which left only hard to achieve improvements for the technology. But this was also partly driven by manufacturers turning their R&D efforts to the advanced technologies, TOPCon, heterojunction, and back contact. For heterojunction and TOPCon, these 2 technologies are currently competing for the middle ground in terms of efficiencies. And with heterojunction, it has started to pull away from TOPCon in recent quarters, but TOPCon continues to dominate all the other technologies in terms of market share following a rapid transition from Mono PERC to TOPCon. But nothing is ever that simple, and not all modules of a technology category are equal. And what may be surprising to those who don't often see data like this is the large efficiency range within a technology. And as there are such a wide range in efficiencies, it's particularly important for distributors and installers that have purchasing decisions to note that the highest efficiency of any given technology category can outperform the lowest efficiency of any other category. So for example, the highest efficiency Mono PERC module will exceed the lowest efficiency module of any of the advanced technologies. While this data holds a lot of information, it's important to remember how quickly this can change as manufacturers release new products and new data sheets into the market. For example, the graph on the screen now is an extract from our Q1 report, which features in the white paper. But IRooftopSolar has already beaten its own previous efficiency lead and has pushed the maximum efficiency of the back contact category even higher, and therefore the market as a whole. Now, module efficiency is only one of the different parameters we can evaluate module performance by. We also analyze metrics like temperature coefficients and bifaciality, and here I'm showing module degradation. Now, the degradation of a module describes how the efficiency will decrease over the lifetime of a module. And this is an important metric, as when modeling financial benefits of a system over its lifetime, you obviously want to take into consideration the performance of the modules over their lifetime, and hence how the power output will degrade over time. The advanced technologies, TOPCon, heterojunction, and back contact, all have better performance in terms of degradation in comparison to the previously mainstream Mono PERC. Again, this analysis is built on information from manufacturer datasheets. If third-party testing data to see how certain metrics like degradation perform in the real world, if that would be of interest to you, please get in touch to hear more about our solar technology and cost report that we publish quarterly with PV Evolution Labs of the Kiwa Group. So to move on to the modelling that features in the white paper, we started modelling by analysing the energy generation of the advanced technologies in comparison to Mono PERC. The focus for the white paper was the European market, and therefore we chose to investigate the energy generation and in turn the financial metrics for 6 key regions in Europe: Germany, Spain, Italy, France, Poland, and the Netherlands. And for each region, we modelled using the capital city. This analysis was performed for both commercial and industrial, and then residential systems, using average system sizes of 150 kilowatts for C&I and 5 kilowatts for residential installations. Now, there are some unsurprising conclusions from this initial energy generation analysis, which is that the higher efficiency technologies produce more energy over the lifetime of the system. And we saw earlier, a few slides previously, that the back contact technology currently has the highest efficiency, and this corresponds to the greatest energy generation compared to heterojunction, TOPCon, and also Mono PERC for both the C&I and the residential modelling that we performed. Now, before getting to the financial results of the white paper and discussing how the module performance parameters and the energy generation combine to give payback time and LCOEs, I'll briefly set the scene of the modelling through the assumptions that were used. For both residential and C&I modelling, there were a number of assumptions which were used to model a PV installation in each country. And as much as I would love to, I don't have time to go through all of the assumptions now, but I've chosen a few key ones to highlight here. For each technology category, we selected performance parameters which belong to the average of the highest performing module series that was an appropriately sized series for the system, whether that would be residential or C&I. Then a price per watt was assumed for each module technology. So that's the graph that you can see on the top left. In today's market, where spot prices have been declining rapidly, there may be modules on offer for lower pricing than what we use in our modelling, so do keep that in mind. Other financial inputs to the modelling included electricity pricing per kilowatt hour for each region, and also overall system cost for the whole system, not just the modules. So that included components like inverters, for example. As with any modelling, the exact financial savings of the different PV technologies, this will depend on the exact system and the exact assumptions modelled. The results that I'll show on the next slide, we advise you use a guide or indication of what range of savings an advanced technology can provide, as the exact financial savings, that'll depend on a number of variables, including the exact location within a country, the orientation and design of the system, and obviously things like the exact choice of modules and inverters in the system. Okay, so now for the results. We've modeled two parameters for the two different system types. For residential systems, which is shown on the left here, we've used payback time, which is the time taken for financial savings from the system to offset the initial cost of the system. And then for C&I systems, we've used levelized cost of electricity, or LCOE, which is the average cost of the energy generated over the course of a system's lifetime. And yeah, that's on the right on this slide. As with the generation graph that I showed a few slides earlier, the results here are presented for the advanced technologies in comparison to Mono PERC. You will notice that on the left in the residential modeling where we show payback time, there's a greater variation in the results between the different countries than there are in the C&I modeling. This is due to there being more variation between the financial inputs to the modeling, because it incorporates things like incentives, regulations, and electricity prices, which have a more meaningful impact on the results. As you can see in both sets of the system modeling across all the regions investigated, the advanced technologies offer the greatest savings in payback time and in LCOE. Also, despite having the largest upfront cost of the advanced technologies, in our modeling, back contact is able to provide the greatest savings in payback time and in LCOE in comparison to Mono PERC. Therefore, initially more expensive module technologies may be able to provide end users with financial benefits alongside other gains, such as aesthetic benefits, for example, that often come with the premium modules. So to conclude the results that I've discussed today, the back contact technology has an impressive efficiency lead over Mono PERC, heterojunction, and TOPCon. But these higher efficiency modules, they come with a price premium. The advanced higher efficiency technologies offer higher energy generation in kilowatt hours across our modeling. And then in turn, these advanced technologies offer benefits in payback time and LCOE. And this is particularly true for the back contact technology when it was modeled with our assumptions. But remember, the exact savings of an advanced technology in financial terms, it'll depend on the specific system modeled. However, the more expensive technologies might just end up providing the most financial benefits over the lifetime of the system, despite the upfront cost. So this is my final slide for today. The white paper is free and it is available to download now from the Exawatt website. So if you head to the website and head to the white paper section, you'll find a version to download there. Feel free to get into contact with any questions, and thank you for listening.
Thank you, Molly. That was a very, very interesting presentation. Just a few questions here. So in your presentation, you mentioned about back contact, offering the highest efficiency. But what do you think of the market share of back contact technologies in the future?
Yeah, so currently back contact, it does sit as a niche technology and it doesn't have a great deal of market share, especially when you consider it in comparison to TOPCon, which has an overwhelming portion of the capacity at the minute. So I would say that back contact, I wouldn't be surprised if it stayed a niche technology. It's only split between a handful of manufacturers in the future. And I imagine it will stay niche, but with high efficiency for more premium applications in the near future.
Interesting. Also, just one question. So are you checking the modules are available commercially in your white paper, as you mentioned, or you're just going by the data sheets, or how is it?
Yep, so the modeling in the white paper, the module parameters that went into that, they were commercially available modules, and the information was gathered from the performance parameters were collected from manufacturer data sheets of available modules.
All right. Thank you so much, Molly.
Thank you.
If you can join the chat, probably start some discussion there. That'll be nice.
Thank you.